When a body is projected from certain height or from a top of a tower, then the motion of a body thrown vertically up from the top of a tower, then what is the value, what is the distance we can find out. Means a body, a tower of small h AB, a tower of small h AB. From this tower, a body is projected vertically upwards to reach its maximum height C, to reach the maximum height C, and after reaching the point C, and the body will started falling downward direction and reach to the point of foot of the tower. Means AB is the small h is height of the body, means tower, and whenever our body is projected vertically upwards, reach the h height to C, reach the C, and after it is downwards falling. The distance travelled by a body in projected direction can be taken as positive, and opposite direction taken as a negative. Means vertically upward direction taken positive and downward direction taken as a negative. The total height will be h plus h, means that is a minus. The upwards taken as plus h, and downwards direction will be minus of h plus h, means the value which has taken. The height reached means vertically upwards, the height reached, or we can say that the displacement reached vertically, that is s is equal to plus h, and in the direction of whenever the body is projected vertically upwards and the total from the height of small h, then it reaches down falling. Means the displacement of a body, means here we can say that BC is equal to plus h and CD is equal to minus of h plus h. Then the total displacement will be from B to D. B to D means here the distance which is equal to h, means here the body displacement is in this direction, so that's why we can consider that is s is equal to minus h, as well as we can get the same thing because of by adding the two equations, then BC plus CD that is equal to, we can get that h minus of h plus h, that is equal to minus h. The total displacement, net displacement s is equal to minus h, and the acceleration due to gravity, that is A is equal to minus g because of it starting upwards. The body is started upwards, projected vertically upwards, so that's why A is equal to minus g. Then reached s is equal to minus h, and it is having that initial velocity, and also that is u is equal to the time taken by that is t. So that's why we are substituting this from s is equal to ut plus half at square, that is the equation of kinematical equation, second equation of motion. So from that equation we can write that s is equal to minus h, u is equal to u, t, we have that a is equal to minus g. So if you substitute that one, half of minus g into t square, so minus h is equal to ut minus half gt square, we can write that, or in this case of we can write that minus h is equal to ut minus half gt square. By taking this minus means h is equal to minus ut plus half gt square also we can write. This is the equation for whenever the body is projected vertically upwards from the top of a tower, motion of a body from the projected vertically up from the top of a tower, when the direction can be taken, the direction of projected side, whenever in the what direction we have projected, if the displacement distance travelled by a body in the same direction taken as positive, and opposite travelled distance can be taken as a negative. So that's why we have taken that the plus h and CD is equal to minus of h plus h. The net displacement will be h minus of h plus h. So that's why we can get that minus h, and the time taken by the body is t, and acceleration due to gravity, that is A is equal to small g, because of at the starting stage we applied the force. So that's why we will consider whenever the body is projected direction. So that's why here A is equal to minus g. From these total values we are substituting in this kinematical equation of motion, second equation of motion, that is S is equal to ut plus half a t square. We can get this equation, a minus h is equal to ut minus half gt square, or h is equal to minus ut plus half gt square. By using this equation, so we can find out the what the height, at the what height the body can be projected, from the top of a tower or at some height. Let's discuss about some problems in a motion in straight line. From the starting that, here we are discussing about a car travels the first third of a distance with a speed of 10 km per hour, the second third at 20 km per hour, the last third at 60 km per hour. What is its mean speed over the entire distance? What is the total? Is nothing but the equation for the average speed. So we know that formula for average speed means here the body started from our point and reached another point, which is having the 3 stops, means it's the first one, total 3 divisions it is have. The car travels first third of a distance, that is velocity v1 with 10 kmph means kilometer per hour, and it consider A, B, C, D. From the B to C, that will be velocity v2, that is 20 km per hour, and at the last third one is v3 is equal to 60 km per hour. So here it is the v1, v2, v3 values are given. From the relation we can write that the average velocity, whenever the 3 velocities are given, the equation is 3v1 v2 v3 by v1 v2 plus v2 v3 plus v3 v1. This is the relation we have. Already we discussed about this one. So that is 3 into what is v1? 10. We are not changing this one. We will finally, for at the result we can change into the meter per second. Now we are taking it in kilometer per hour. So 10 into 20 into 60 by v1 into v2, 10 into 20 plus 20 into 60 plus the next one is v3 v1, 60 into 10. So here the values are here 10 20, can continue this one, here 3 zeros is there, 6 2s are 12, 12 3s are 36, so 36,000. So totally 36,000 be the 3 into 10 into 20 into 60, 3 10s are 30, 30 20 600, 600 into 60, 36,000. Then from that 10 into 20 200 plus here the 20 into 60 1200 plus 60 into 10 600. From this relation 36,000 by 1200 200 1400 1400 600 2000. So 2000. Here 3 get cancelled, 2 ones are 2 18s are 18. So 18 kilometer per our average speed. To change this into meter per second, we can multiply 18 with 5 by 18. Then we can get the 5 meter per second. 5 meter per second is the value of average speed, mean speed, whenever the car travels from the first total distance, entire distance. 5 meter per second be the value of average speed, average or mean speed. Mean speed, that is equal to 5 meter per second. This is about. The next problem is a bullet moving with a speed of 150 meter per second strikes a tree and penetrates 3.5 centimeters before stopping. What is the magnitude of its retardation in the tree and the time taken for it to stop? after striking the tree. After striking the tree. So here is the values. We can get that a bullet moving with a speed of 150 meter per second means a bullet speed is u is equal to 150 meter per second. And the strikes here tree and penetrates 3.5 centimeters. The displacement strikes here tree and 3.5 centimeters means the displacement which has happened 3.5 centimeters, which can be transferred into the meter per second, means it is in CGS system, so we should convert into the SI system. So a bullet moving with a speed of 150 meter per second, that is initial velocity u is equal to 150 meter per second, and it penetrates 3.5 centimeters means the displacement s is equal to 3.5 centimeters, that can be converted into the meter per second, that is 3.5 into 10 to the power of 2 meters. So here it is. Then here before stopping means it already body it comes to rest, that is velocity, final velocity will becomes a 0. Then what is the magnitude of retardation? He asked for retardation from v square minus u square is equal to 2as. From this relation we can write that minus u square is equal to 2as. That is retardation means a is equal to minus u square by 2s. This is a relation of a retardation. Negative symbol indicates that retardation means here the retardation is depends on the velocity also. So that's why we are substituting the total values in the equation. Then we can get that a is equal to u square minus of 150 whole square by here 2 into 3.5 into 10 to the power of minus 2. From this relation by the calculation we can get that values, that is 3.214 into 10 to the power of 5 meter per second square. By the calculation we can get 3.214 into 10 to the power of 5 meter per second value. So from that value, another thing is, then he asked for another one also, what is the magnitude of retardation is in the tree and the time taken for it to stop after striking the tree. After striking the tree, then what is the time has taken to reach? Means stopping distance, means whenever the retardation started, whenever it penetrates the tree, retardation started, then what is the time has taken to stop by a body. So here it is that the time is equal to u by a is the formula we have. From that formula we can write that t is equal to u means 150 by, here negative symbol indicates that retardation. So a is equal to 3.21 into 10 to the power of 5. From that relation also we can write that by the calculation 4.67 into 10 to the power of minus 4 second. The time taken to stop the body. Time taken to stop the body. Means here, consider it's a tree. When a bullet is started with initial velocity u is equal to 150 meter per second. Then it is penetrates through the tree and stopped at certain distance, that is 3.5 centimeter. Then from the starting it started penetration and stopped at some distance, v becomes 0. Final velocity becomes 0. So that's why then here we are going to know this, the retardation, how much the velocity goes on decreasing after penetrating the body. Then here another one is derive an expression for stopping distance. Stopping distance, what is meant by the stopping distance? Let's see, when we are riding the bike or when we are riding the bicycle, if we apply the brake, immediately that body cannot be stopped. It will move for small distance until it stops. The time between the distance travelled by a body to stop after applying the brake, the distance travelled by a body after applied the brake, the distance travelled by a body before stop, the distance travelled by a body before stop after applying the brake is called stopping distance. Stopping distance means we apply the brake and that body has moved some distance and stop. So the distance travelled by a body after applying that brake is called stopping distance. So here it is that body is moving with initial velocity u, and that is stopped at distance of some of the distance traveled. So v is equal to 0. Then s be the displacement, that is stopping distance. From the relation, so simply we can get that from the v square minus u square is equal to 2as also we can write that, and as well as here we want to know this, here s is equal to s and a is equal to a and v is equal to 0 minus u square. Here negative symbol indicates that the retardation. Here we are already discussed about the retardation discussed. So that's a minus u square by 2a, that is equal to s. This is the formula for stopping distance. Here this is about the problems which are important in the motion in a straight line.